Hey YouTube, and welcome back to Beanie Games. Today we'll be continuing our series of videos on solving the Sudoku Puzzle Hunt with what I believe is the hardest puzzle in the collection. I've read through a lot of the feedback on the Patreon page and Discord channel, which have similarly also found that this puzzle has been a roadblock in this puzzle hunt. And so I hope that this video will be able to help those over this hurdle and continue on with their journey. Now, for those of you who haven't yet tried the puzzle hunt, I strongly recommend you do so, and the link for this can be found in the description below. Now let's get on to the puzzle. Last time on the channel, we were able to solve It's Up in the Air, and we have saved the solution grid here. The next thing that we need to do in the puzzle hunt is to work out which puzzle we are meant to solve next. For those of you who have already discovered the theme of the puzzle hunt and have worked out which puzzle is next, feel free to skip ahead to the solve of the Sudoku. A timestamp should be available in the description below. For those of you who have used the brute force approach to puzzle 1, we're going to continue along that path in this video today to work out which puzzle goes next. Fortunately, we can recall that one of the rules of the puzzle hunt was that the contents of the circled cells are to be used to fill the equivalent cells in the next puzzle. So it seems that we should be able to use these clues to work out which one is next. Now, fortunately, I've added the circles to our solution grid and from last time, and we should be able to compare these with the other puzzles that we need to that we have here to work out which one is next. Now, if we start looking at a raging temperature, we can see that the rules for this puzzle are that normal Sudoku rules apply, and in addition, each thermometer must strictly increase along its length from the bulb. Now, looking at the numbers that we have here in our circled cells, we can see that this 9 here is going to cause a bit of a problem, because this 9 is going to translate to this cell over here, which is along this red thermometer, but not at the bulb or at the end. As such, there's going to be a contradiction if we were to try and use these digits to solve this puzzle. Okay, so we can say that a raging temperature is definitely not the next puzzle that we are meant to solve. Now, if we look at forged letters, we might be able to quickly exclude this because once again we see that it doesn't have any circle clues, and we might be stuck proceeding on in the puzzle hunt. However, if we look a bit closer, we can see some of the rules here. So we can see that there's similarly some thermometers which follow the same rules as above, and there's also a kilocage set of rules in which the shaded areas must contain no repeated digits and sum to the value in the top corner here. We also have sandwich clues, which indicate the sum of the digits between the 1 and the 9 in a given row or column. Now, for those of you familiar with sandwich or kilocage variants, you might know that there are some restrictions on what the maximum values sandwich clues and kilocages can have. Here, so we can see that a sandwich clue, AR, cannot be greater than 35. And as such, A needs to be 3 or less. Similarly, we can use this AD kilocage clue to also show that A, in fact, actually has to be 2 or less, because the only way to get 4 digits to add up non-repeatingly would be to have a 6, 7, 8, and 9, which adds up to 30. However, this D here can't possibly be a 0, as it's one of the digits in the grid. So this probably has a maximum value of 29. And so we can see that this A here, which matches up to this 9 in our circled cell, is probably going to cause a contradiction. And likely, once again, we can see that forged letters is not the next puzzle that we are meant to attempt. Moving on, we can see hostile killer has similarly those kilocage rules which we discussed earlier. Now, a contradiction can be seen when we look at this box here, this 21 cage. So we can see that a 2 is going to be passed down from it's up in the air to this cell down here. And then we would then require these two cells to add up to 19, which is impossible because the maximum we could have would be a 9 and an 8, and that's only 17. So once again, Hostile Killer is not going to be the next solution, our next puzzle for us to solve. Hungry for Sandwiches has those similar set of rules to those sandwiches clues that we saw before. However, we're seeing that these sandwiches can indicate the numbers summed between the 1 and the 9, or the 3 and the 8 in a given row or column. Now, if we look once again at our set of circled cells, we can see that there's a 9 and a 1 here, right next to each other in this middle column. As such, if it was going to be if these cells were going to be passed down to the Hungry for Sandwiches puzzle, we would require one of the two sandwich clues to be a 0 in this middle column. Given that we have 34 and 13 as our two clues, we can see that these set of circled values can't be passed down to Hungry for Sandwiches. So we can also exclude that as the next puzzle to solve. Now, looking at hypocrisy, we once again only have normal Sudoku rules that apply. And we have 11 circle cells, which we're going to be passing digits down into the next grid. Now, for those of you familiar with minimum requirements for normal Sudokus, you may be aware that you require a minimum of 17 given clues for a normal Sudoku to become solvable without any other restraints. And as such, we can also rule hypocrisy out as the next puzzle to solve because we won't have enough digits to provide a unique solution. Now, It's Up in the Air is obviously the puzzle that we've already solved, so we can move on now to Lascivious Queens. Now, Lascivious Queens is interesting in the sense that we have two 9s here which are given, which match up to two of the 9s in our circled cells. Similarly, we can't find an obvious contradiction to begin with, so we might come back to this one later. Moving on to Overgreedy. So there are a couple of ways we can rule out this as being the next puzzle in order. And I think the quickest way to do it is to notice that this 5 here would be passed down to this cell. And this box already has a 5 in it. So we'd have a contradiction. And once again, so that's probably the easiest way we can say that Overgreedy is not the next puzzle for us to solve in order. And for schismatic nonominos, this might be the easiest way for us to exclude, but we can see that 9 in the top corner here, this 9 in the top corner here cannot be passed down to this 1. We'd have a clash and once again a contradiction. So we're left with only Lascivious Queens being the possible next puzzle for us to solve in order. So let's open that up in a new tab and let's try and solve that puzzle. Now let's once again add the rules. And so we can see that normal Sudoku rules apply. In addition, the Queen rule applies to the digits 4 to 9. And i.e. this means that each of those digits must appear at most once in any given diagonal. There is no restriction on the remaining digits. Okay, now what we should do is add all of our circled values back down into this grid, so hopefully that it will now become solvable. So we can add a 9 and a 1 here, a 2 there, we can add a 2 here, a 5, 4, 3, 2, and I think we can also add a 1 here. Okay, so now we should have the 11 cells that were in our circles from It's Up in the Air, which are these cells right here, And now we have also the other given values from Lascivious Queens, and hopefully we're now going to be able to solve this puzzle. Now, the way to go about starting this puzzle, I think, is going to be to look at the nines. We have 3 nines given in this puzzle, and as such we should probably see how restricted the remaining nines are in the grid. Now, this 9, we can see, can rule out a 9 from these values as well as this diagonal. Now, I might colour those red to make this a bit obvious. Once again, this 9 has ruled out 9s from these cells, along this diagonal, and along this diagonal. And we can actually rule out this column as well. Okay, and we use this 9, we can see that the remaining row and column can be ruled out, as well as this diagonal and this diagonal. We might also shade the other cells that we are given, which are not 9s. Okay, and we start to get this picture here. Well, we can see in this box, there's now only one cell in which a 9 can go, and so we can place that here. We can then also now use this 9 to rule out a 9 from those 2 squares, and along this diagonal from this cell here. Okay, and now we can see that the 9s are actually quite restricted in the rest of the puzzle. In fact, given that we know a 9 must be in this row in this box, we can rule out a 9 from this cell here and make that one red. And now we reach kind of a bit of an impasse. However, we should note that the 9s in this cell, in this box and this box are going to interact on each other as well. So this cell, if this cell is a 9, this cell would have to be a 9, because this would cause, this value here would rule out this cell by the diagonal restraint. Similarly, this cell would rule out this one by a diagonal restraint, and this one would become a 9. So maybe we'll highlight those 2 as yellow and those 2 as blue, and see what happens if we follow through with this yellow path. So if the yellow values were going to be 9s, we can see that this cell, and this cell, as well as these 2 cells, would then become red. Let's make them purple, so it can be a temporary red. So we would then be left with one of these 2. Actually, we can see that this one would also become purple, and so we would force this one to become our yellow cell. This would then cause this one to become red, and then we would have to have both of these become yellow. And we can see that we can't do that because we would have a contradiction in the diagonal constraint. And so these yellow cells have actually can't be the set of 9s, because we have this contradiction that we end up with. So let's get rid of all of those shading. And let's go see what happens once again if we use those blue cells, where we can place our 9s. So this blue rules out a 9 from those 2 cells, and this blue rules it out from this cell. So this one would become a 9. Okay, this cell would rule out these 2, and we can place a 9 here, and we're left with one cell in which a 9 can go, this one here. Alright, so we now have a correct positioning of all of our 9s in the grid, and so we should put 9s in all of these cells. Now, while we get rid of all the other shading, I should mention that this is one way to go about solving this puzzle. I know lots of you have found other solution paths, but I've found that using a cell shading technique has led me to reach the correct solution in the most logical way for the way that I think. And it's probably as a result of being the compiler of this puzzle, because when I discuss this in a future video on the making of Lascivious queens, we can see that making queens puzzles are actually quite restrictive. Now, the next thing we're going to do is look at the fives. And so once again, we should color out all the cells in which these fives act on. So this 5 here rules out these cells, and this along the diagonal, and along this diagonal. And this 5 rules out this box with that column there. Once again, we'll make those red, and we can make other values that are not 5s also red. Okay, once again, we can see that we've got only one option for a 5 in this cell in this box, so let's place a 5 there and continue on colouring in red values. You can pull out 5s along that diagonal. Okay, and so we're left with, actually I've missed a couple of red cells up there, to make sure I'm not missing any others. Okay, I think that's going to be enough for us now. Okay, so once again, let's shade some of our other options in. So we can see that these are going to be quite restrictive based on which cell here is going to be a 5. In fact, this also acts on this box here. So let's make this one yellow and this one blue. Okay, and let's go through trying to solve. Let's try and solve for yellow. Okay, so if yellow was a 5, you can see that these would not be a 5. We'd also get 5s ruled out from all of these cells. We could see that this would then become a yellow 5, and I think we're going to find a problem because now there is nowhere for us to put a 5 in this row. We can see that this 5 has ruled out this cell, this yellow one has ruled out this cell, and this cell, and the remaining 5s have ruled out the red cells that we've already coloured in. So we can see that this yellow cell, in fact, can't be our set of 5s. So this blue cell is going to be our 5. Let's make and so we can colour in these values here and here. Let's colour those ones out and colour those ones out. Okay, we only have one cell left in this box, which can be a 5, so we'll place the 5 there, and that'll give us a 5 in our top box, which will in fact finish our collection of 5s. And we get a 5 here. Okay, so now we've been able to use the Queen's rule and just a couple of values of 5s and 9s in the grid to reach all, to find all the 5s and 9s in this puzzle. Now, we can probably use a bit of normal Sudoku now to find a couple of other digits in the grid, mainly in this center box. So we can use this one and this one to place a 1 here, and we can use this 2 and this 2 to place a 2 in this middle cell. Now, having seen lots of the feedback, this seems to be the point in which most people get stuck in this puzzle. And so we're going to go through a similar cell shading technique to try and work out the next numbers that we can obtain in this puzzle. Now, we can see that these 3 cells each have to be the number 6, stuff that up, 6, 7 and 8. Okay. And what's unique about this is that these 2 cells act on both these cells and this cell by a diagonal. So if either of those 2 cells was a 6, 7 or 8, let's have a look at this one. So if this was a 6, we would rule out a 6 from all 3 of these cells by Queen's rule. Similarly, if it was a 7, we would rule out all 7s from this middle box. And if it was an 8, we would rule out an 8 from all of those boxes. So this cell and this cell can't be a 6, 7 or 8. So we know if we look at the remaining numbers in this row, these 2 cells are going to be a 3, 4 pair. In fact, that's going to result in this cell over here becoming a 6, 7 or 8. And furthermore, we should be able to know that these 2 cells are going to have the same value. I'm going to color those blue because we're going to come back to that shortly. Now, looking along this row, we can also put in some numbers. So we're left with 1, 6, 7 and 8 as the values that need to go in this row. So I'm pretty sure that's how we can do it. And the only other thing that I'm going to do is put the options of what can go in this cell here. Okay, and we'll come back to why we're going to do that. So this cell, so we can see in this column that we're left with a 2, 4, 6, 7 and 8, but this 7 here rules out this 7. So we're left with a 2, 4, 6 or an 8. Now, if we look at this box over here, this 8 has quite a lot of power. This 8 rules out an 8 from these cells and these 2 cells. And these cells already have values in them from our 5 and 9 earlier. So we're left with an 8 being in one of these 2 squares. And we can now see that given that 8 is going to obey our Queen's rule command restriction, we're going to be unable to place an 8 in this cell. Otherwise an 8 would rule out there'd be nowhere to place an 8 in this box. So we can get rid of the 8 here. Now, this 6 is also going to have quite a profound effect on this box. Because if this cell was a 6, a 6 would be ruled out from both of these squares, this by normal Sudoku and this by Queen's rule, which is going to force a 6 in both of our blue squares. Now, coming back to the blue squares, if we can actually look and see that these blue squares cause quite a restriction on the remainder of the grid. If we look at about where the value of a blue square can go in this box, we can see that this cell is going to rule out these 3 by normal Sudoku, this one by Queen's rule, as well as this one, and this one up here is also going to rule out this cell by Queen's rule. This one obviously has a 9 in it and can't be a 6, 7 or 8. So we're going to know that one of these two cells is going to be a 6, 7, or 8, and it's going to be the same value of the blue cell. We're actually going to get a similar restriction down in this box. So along this diagonal we can see that these two cells are ruled out, and along this column we can see those two cells are ruled out. And the 5 and 9 are already also ruled out. So we're left with the 6, 7, or 8 in one of these two squares. Now I'm highlighting these in yellow because given that we know one of these values is going to be in this column, that's going to provide restrictions up here in the grid. So if we look at where the blue cell's value can go in this grid, in this box, well, it can't be in either of those cells. These yellow options down here exclude it from those three cells, and this diagonal rules it out from this cell here. So the value is going to be in one of these two squares, either a 7, or if it's a 6 or an 8, it'll be up in this cell. In this box, it's going to be one of these three cells. And that's once again because these two options rule out these three cells. This blue cell rules out those three cells, and so we're left with these three. However, we should note that this cell can't be a 7 or an 8, and so it can only be a 6. Now, we're going to do this for the rest of the grid, and then we're going to come back and test whether this cell can ever be a 6. So, in this box over here, we can clearly see that it's going to be these three options. And in this box over here, we're going to see that this blue cell rules out these two cells. And so we're left with these three options. And I think this box down here is going to be our least restricted option. This blue cell will rule out these two cells, but we're going to be left with quite a lot of options, including this 8 here. Okay, so what I'm going to do now is shade in, let's make this red, let's make it green. Let's say if this is a 6, it's going to force our blue cells to also be a 6. And so we can see with 3 6s in the grid, what happens to the remaining 6s. Well, we know that up here, this cell would have to become a 6. And now that we have 2 green cells, we know that this cell is going to have to become a 6. Along the diagonal, we can now see that this green cell is going to rule out this cell, so this would have to become a 6. We can once again use Queen's rule to rule out this cell down here. This is going to have to become a 6. These 2 green cells have ruled out these options here, so this is going to become a green cell, and we're left with one last green value. The problem with this assortment of cells is that we have a contradiction along this diagonal. This position of 6s around the grid breaks our queen rule. So, this cell can never be a 6. And so, similarly, it can never share the value of one of our blue cells. Now, I'll make those green options yellow again, but we can see that testing the numbers of these blue cells has quite a restrictive effect on where that value can go in the remainder of the grid. So now that we've ruled out this cell as being able to contain the same value as our blue cell, we can check again for 6, 7, and 8 what happens around the grid. So let's once again check for 6. If these are 6s, this one will still be a 6. We'll get a 6 here, and a 6 here. I believe this cell is going to work on this diagonal to rule out a 6 from here. So we're going to get a 6 there to rule out this diagonal, a 6 there, and we've ruled out these two columns, these two rows now. This is obviously an 8 and can't be a 6. We're going to be left with a 6 here, which is going to cause a contradiction in column 9 of the grid. So these can't be 6s. Our blue cells can't be 6s. Now, so we can see now that this is, let's get rid of those 6 again, and we'll make these yellow. I've stuffed that. Let's make those cells yellow. And now let's check what happens if it's an 8. So if these cells are 8, once again, we're going to get a similar array of digits, except now we know that this cell will be our green value. And so we can place this one as a green. Once again, we're going to work on this diagonal. And so this cell will become green, this cell will become green. But once again, we can see we're going to have a clash. Our Queen's rule is going to break if our blue cells are 8s. So we've now ruled out 6s and 8s from the values of these blue cells. So we're left with 7s. Alright, and so we know that this cell is going to be our blue 7. And now, what happens with our remaining options? Well, this 8 obviously can't be a 7, but we're left with this, actually this cell can't be a 7, but we're left with this arrangement of possible 7s around the grid. Similarly to when we used our 9s and our 5s, we can make one of these purple and see what happens. So if the top cell is purple, this one will become purple. That will work along this diagonal to rule out a purple from this cell. So this one would become purple. This one would become purple. This one would become purple. And this one would become purple. Now, I believe that that is a workable set of 7s. So we'll just double check and see what happens if the other value was our 7. So if that was green and that was green, well, 7s would be ruled out from this cell by normal Sudoku and this cell by Queen's rule. So this would become a 7. That would work on this diagonal down here. We would have to have a 7 here and a 7 here, which would rule out these cells, and we'd be left with a 7 here. Okay, so if the green option of 7s, if the green cells were going to become our 7s, we would find that we would get a contradiction, once again, along a diagonal. However, the purple cells don't have any contradictions. And so we can see that the purple cells are going to be the arrangement of 7s, if I can type them in properly, in this grid. And I appreciate that that's quite a hard thing to see, particularly, and obviously I've had some insight into the next step to do in the puzzle hunt, in this solve of the Sudoku, because I was the compiler of this puzzle, but I hope you can all see how that logic worked. So we're going to rule out a 7 from these cells. We can rule out a 7 from these two cells as well. Okay. And now we can see that we've got the 5s, the 7s, and the 9s now placed in the grid. Now we're going to have a similar logic using these cells here to now proceed. This cell, if it was a 6, would rule out a 6 from both of those cells by Queen's rule, and a 6 would then be placed here. Similarly, if this was an 8 would be ruled out from both of those cells, and an 8 would then have to be placed here in this row. So we know that these two cells are going to have the same value. With that, we can see that there's quite a restriction on where these blue cells can now be placed around the grid. And we can look at this top box up here to start with. So, these cells are ruled out by this blue cell, and along this diagonal, this cell is ruled out by that blue cell. So we know that this cell is blue, and it's going to be either a 6 or an 8. That's going to form a 6-8 pair in this column, so we can place a 2-4 down here to be the opposite pair. Now, this 6 has ruled out, this blue cell has ruled out those two cells, and this diagonal has ruled out this cell. So we know that this must also be a blue cell, and must also be a 6 or an 8. We can now use these blue cells to rule out those 6 values from the top, the first box, and this blue cell to rule out this cell along the diagonal, and we're going to get another 6 or an 8 and a blue cell. Okay, so now we've got 5 blue cells in the grid. In fact, these these blue cells have forced a blue cell into one of these two positions. In fact, we can see that this blue cell has ruled out those three cells, and this blue square has ruled out those 3 cells, plus this cell along the diagonal. This can obviously not be a blue cell, it's a 7, not a 6 or an 8, so we're left with just this one value, this given 8, which is going to be our blue cell in this box. Now, we know all these blue cells are the same value, so we can make them all 8s. We can make this one a 6, as it's a 6-8 pair. We can get rid of the 8 from there. Okay, and we should be able to now place, so we should have 3 more 8s to place in the grid. You know, one of them is going to be here, one of them is going to be here. In fact, this 8 and this 8 and this 8 have ruled out all these cells, so we're left with an 8 down here. This 8 and this 8 have ruled out those cells, and so we're left with one of those options. In fact, I've missed it. This 8 here works on this diagonal to rule out that cell. So we're left with an 8 here and an 8 there. And once again, we've been able to place another one of our queens into the puzzle. Alright, and we're making quite a lot of good progress now, and we'll see if we can place, let's just place the remaining options in the remaining cells and see if that's going to help us now. So we're left with a 1, 3, 4 and 6. These are all possible. This cell can't be a 4 due to Queen's rule. This is also going to be 1, 3, 4 and 6, but this cell can't be a 6 due to Queen's rule. We're going to have a lot of these 1, 3s, 4s and 6s. We should be able to now, so yeah, we can, where does a 2 go in this column? Well, a 2 can't go here due to that 2. It can't go in any of these cells due to that 2. So we're left with a 2 there. Okay, and where does a 2 go in this box? Well, this 2 and this 2 have ruled out those options, so we're left with a 2 here. Okay, and so where does a 2 go in this box? Well, a 2 can't go in those cells, and this 2 rules out those 3. So we're left with a 2 down here, which is going to give us a 4 up here, and we're going to be able to start tidying things up. So the 4 also obeys our Queen's rule, so we can remove 4s from that diagonal. We're given a 3 here. We've now got a 1, 6 pair, so this is also going to be a 4. We can remove this 4. And we're left with a 1, 3, 6 triple, so this is going to be 4 in this box. Now this 4 rules out a 4 from both of those cells, so we can place a 4 here. This 4, this can no longer be a 3 or a 4, that's also a 1 or a 6. In fact, I'm going to highlight the 4s that we've got now, just to keep track of them, because that's going to be able to give us the remaining 4s in the grid. Okay, so in this box up here, well, this 4 acts on both this cell and this cell, so we're given a 4 here. Make that blue as well so I can keep track of it. We've got 4s here, and let's see, we have a 4 down here, and that's from these 3 4s, and we're left with this cell being the final 4 in the grid. Okay, so now we've got 4, 5, 7, 8 and 9 as our queens that we've placed in the grid. We only have 6s left as our last queen, but we also only have a couple of cells left in each box, so we should hopefully be able to now solve this pretty quickly. Okay, so a 3 here and a 3 here places a 3 in this cell. That's going to place a 3 up here, and that's going to become a 6. And we can use this 6 along this diagonal to place this 6 here, and that's going to become the 3. Where can we place a 6 in this column? Must be up the top. We're left with a 2, 3 pair, which is also resolved by this 3. So that's going to be a 2, that's going to be a 3, that's going to be a 2. We've got 1, 3 and 6 remaining in this box, but that one can't be a 3. You know, that one was also a 1 and a 6. This one was also a 1 and a 6. No 1 and a 6. Okay, so we've got all the options in here. We might just highlight the 6s that we've got, because that's probably going to be where we're going to be able to resolve this. Yeah, and in fact here we can see this 6 works on this cell by the diagonal, so that's going to become a 1. And actually also works on up here, so that's going to become the 3, and that's going to become the 6. Let's make that one blue. It's going going to resolve this 1-6 pair here. Make that one blue. Resolving that 1-6 pair. Also resolving this 1-6 pair. Okay, we should have this one as a 1. This is our last 6, and that's our 3. Okay, and we can now check that. Looks good to me, and there we have it. That's the solution to the second part of the puzzle hunt, Lascivious Queens. Once again, we're going to use our snipping tool to keep a copy of our solution grid, and we're going to add that as a new slide just in here. Let's get rid of those. Okay, and we can also update our table. This is now going to say Lascivious Queens, and our hashtag cells, if we were to compare to the puzzle hunt, we know that it's going to be this cell and this cell, which if we go back to our grid, we're going to see is a 1 and a 2. And we were told in the original rules to treat these as a pair, so let's write them as 1, 2, or a 12 in our table to keep track of those. And once again, we will leave the asterisks for later in the solve of the puzzle hunt. Thank you all for watching, and I hope you enjoyed the solution to Lascivious Queens. I'd love to hear if you solved it differently. Please leave a comment below, and like and subscribe this channel so that we can let you know when the next video is going to come out for the solving of this